All right, how's it going? So I have about 2 minutes to go through this, so I'm going to quickly go through it. This is my final project for ECEN 160. On top here, I have the hello world function, and on the bottom, I have the ALU tester, which as you can see, all of that functions as it should. So I'm going to hit reset here and go into the part that's important, which is the subtraction. So I'm going to open my subtraction method, which demonstrates the hardware and software version of that. So first I'm going to demonstrate it. 7 minus 3 is 4 and 4 minus 3 is 1. So the first one uses the ALU's full adder and the second one uses hardware functions. Really quickly, these are the functions that I used. These are the steps that I used in order. So here's the prom functions. Here are the values of the decoder, which are read by my system, and then functions are out. And here's a brief description of what they do. Over here, if you're wondering what that is, I have an ASCII code thing that I created myself. So if I put a capital F, for example, 14 and 26, or an A, which is what I'm hoping to get, 14 and 21. So it updates based on what you put in there, which is really cool. Allowed me to quickly code and understand the code a lot better. So to understand the program of what I've got here, the clock increments the counter, which goes into the main logic and then is read by the prom. So the clock also increments in there and also increments the screen. Inside the prom, here's my counter. It goes through the sequences of the prom, which I'm going to reset. So we're at the beginning. We can see here in the prom 1 and 3, 1 will always record to register 0, and 2 will always record to register 1. So we can see here 3 and 7. So those are my numbers. You can see from earlier we had 3 plus 7. So we have 7 minus 3. So we have the 3, which you can see right here, is right here, and that's going to go into the right enable of this first register, which is what I said, and the other one will go into the other one. So we have, so down here we have the code which is to be recorded, and then if I press the T, we can see it being stored in the other one. Actually, I have them backwards. Sorry, this is register 1 and this is register 0. So we restored the 1s go to register 1 and the 2s go to register 0. So I had that backwards. But again, it doesn't really matter. It works right in my code. Just it's backwards here in terms of my logic. So going into here, the decoder will send values as to what is being written and enabled and so forth. So we have here all the functions of my, as defined right here, that are passed in through these hex codes. So the first part goes into the decoder, the second part goes to here where it can be potentially stored by the register. The register then passes it to either the screen if the write is enabled, or into the ALU, or it could even do both if the write was enabled and the ALU was enabled. So it could come down here into the ALU, which we'll look at in just a moment. First, let's look into the registers themselves. So these are made up of a flip-flop with a mux that allows the values to flip-flop as necessary. And the write enable is obviously enabled or disabled based on this write input, so they can't both be written to at the same time based on that input. Going into the ALU, I have a full adder and subtractor, an OR, an AND, and an XOR. Now these ones are obviously consisting of 4 of the same thing, 4 ORs, 4 ANDs, and 4 XORs, but the add subtractor is a little bit different. There's my 4 XORs, and obviously notably because my registers are in reverse order, this is on the A input rather than the B input. These go into the 1-bit adder right here. So going back into here, the restored value of this register goes out and then is potentially read by the mux and stored into the register. So I can show that real quick. Let's go down to right on the 50. Where's my 50? Right. I thought I would have seen it by now. I saw it just a second ago. Anyway, here is my 50. So you can see it right here. There's my 50, which takes the value of 4, which is 7 minus 3, and puts it out here. So we have now the value which is displayed on the screen, which we'll see is on the next tick, 4. So that is the result of the ALU version. So the other one, I don't know if I have time to go through the stages, but it works similarly, but with a different code. So we can see on here is the code for my ALU version, the last part being the display, and here's the part for my hardware. So it works using the exclusive XOR, and I'm going to quickly step through the code to show you that. So it's going to display a little bit of text first, and then it will go into, here we go. Now we're starting to get into some of the code here. So now we're into the exclusive XOR, and so it's working off of the XOR as you can see there. And that is what's being displayed on the screen, which you will see here in a second is the number 1. There we go. But again, I don't really have time to go over that. But anyway, thanks for watching, and thank you for a great help second half of the semester. There is my code for it. I wrote out all the different commands to it so I could follow it and also understand it. It really helped with understanding to write it out. But yeah, thanks for watching.